Vibration analysis. Procedures for accurate evaluation of machinery condition. Common problems. Looseness. Looseness can and does take many forms. The various forms are created by the type of looseness, that is the machine or rotating unit loose, the amount of looseness, and other associated problems such as imbalance, misalignment, defective bearings, etc. 1. Bearings loose on the shaft. 2. Bearings loose in the housing. 3. Common forms of looseness. 4. Noise. 5. Diagnosis of looseness. Vibration analysis. Procedures for accurate evaluation. Looseness. Bearings loose on the shaft. When a bearing is loose on the shaft, the type of signal generated depends upon how the unit is installed. If the inner race is turning on the shaft in an electric motor that is belt driving another unit, the frequency spectra may appear as imbalance with a high amplitude spectral line at motor speed, as in Figure 3. However, the time signal may be distorted in some manner. The time signal may vary in amplitude, be truncated, contain harmonics, contain a beat, or the time period may be different at each half cycle. Some of these characteristics may produce harmonics and other frequencies, such as the speed of the driven unit. On direct coupled units, if the bearing is turning on the shaft, the frequency spectra may contain a spectral line at unit speed and another spectral line a little lower than unit speed. The lower spectral line is the speed at which the inner race is turning. The difference frequency or delta F is equal to the unit speed or how fast the bearing is turning relative to the shaft, as in Figure 9. The time signal will contain a beat caused by the two frequencies going in and out of phase with each other. Vibration analysis. Procedures for accurate evaluation. Looseness. Bearings loose in the housing. When the fourth harmonic of rotor speed is distinctive, the bearing may be loose in the housing. The data in Figure 10 was taken from a motor running solo. Note the overall amplitude is only 0.1 inch per second, and a serious problem exists. The fourth harmonic is distinctive, and the second and third harmonics are present. These harmonics should not be visible with prescribed calibration levels. Caution should be used in diagnosing bearings that are loose in the housing when a pump has 4 vanes on the impeller because the fourth harmonic may be caused by vane pass frequency. Some press rolls may also contain the fourth harmonic of speed. This can occur when the roll has 4 high places. There are many more examples, that is screws that have 4 flights, etc. The only way to determine which problem exists is to look at the phase relationship between the fourth harmonic and the fundamental. If the fourth harmonic is out of phase or is changing phase, the bearing may be loose in the housing. If the fourth harmonic is in phase and maintains a constant phase relationship, the bearing may not be loose in the housing. Another indication that the bearing is loose on the shaft or loose in the housing is careful analysis of bearing frequencies, particularly ball pass frequencies of the outer and inner races. When calculating bearing frequencies, the rotating unit speed is used. The normal assumption is that the bearing is rotating at the same speed as the shaft, and the fixed race is not rotating. These assumptions are wrong in many cases. The bearing frequencies are actually determined by the relative speed between the inner and outer races. If either race is turning on the shaft or is loose in the housing, the bearing frequencies will be less than those calculated. Once again, care must be used because if the contact angle is increased, the ball pass frequency of the inner race will decrease. Careful analysis of bearing frequencies can identify bearings that are loose on the shaft or in the housing. Vibration analysis. Procedures for accurate evaluation. Looseness. Common forms of looseness. The more common forms of looseness could start with an increase in the amplitude of the fundamental and the harmonic content, as in Figure 11. Many unskilled analysts try to solve these problems by balancing. Such efforts may not be successful. As the looseness increases, the harmonic content also increases, and the amplitude of the fundamental and the overall RMS value can actually decrease. The next stage of looseness could be the appearance of spectral lines at fractional shaft speed. These spectral lines could occur at 1/2, 1/3, 1/4 shaft speed, etc., depending upon the type and amount of looseness. The author has observed 1/7 shaft speed when the spacer and outer race were switched on a cylindrical roller bearing. Fractional shaft speed is often generated when the rotor does something different every x revolution. One example is when the amplitude of every other revolution is higher, as in Figure 12. If an event such as a pulse is occurring every third revolution, then 1/3 shaft speed will be present. These events may not occur each and every revolution. However, they must occur several times during the averaging process to generate spectral lines at fractional shaft speed. The amplitudes of these spectral lines can be quite low because they may not be present in every time period. Vibration analysis. Procedures for accurate evaluation. Looseness. Noise. The last stage of looseness is often noise. The noise can be wide-banded white noise or narrow-banded pink noise. Noise contains all frequencies in a defined bandwidth. This machine is moving in an unpredictable manner and is generating all frequencies in the bandwidth, as in Figure 13. Severe looseness is the only problem that can generate such frequencies except for cavitation in pumps. When cavitation occurs, vane pass frequency is generated, and the spectral line at vane pass frequency is normally on top of wide-banded noise, as in Figure 41. Various operational parameters will verify the cavitation problem. Some machines fail before noise occurs. When noise occurs, the machine can and normally does fail in a short period of time. The time period could be hours, days, weeks, or months in some less severe cases, but not years. Vibration analysis. Procedures for accurate evaluation. Looseness. Diagnosis of looseness. The earlier a machine is diagnosed, the more precise and accurate is the diagnosis. The later the diagnosis is made, the more general and less accurate is the diagnosis. For example, early stages of looseness, misalignment, bearing defects, and gear problems can be accurately diagnosed. In the later stages, only wide-banded noise may be present, and the diagnosis may be looseness when, in fact, there are bent shaft, misalignment, and defective bearings present. This is why diagnostics of rotating machinery may not always identify all problems. Accurate diagnosis will always identify the most severe problem, which is often looseness. Thank you.